Hey, these are the notes for 7.4. We're going to be adding or subtracting rational expressions. Okay, so we need to remember when we're adding and subtracting rational expressions, they have to have a common denominator. When multiplying and dividing, multiplying, you just go straight across and multiply everything. We can't do that with adding and subtracting. You have to get the denominators the same, then you can add their tops together. Okay? Well, in these two problems, if we look, the denominators are both 4x on number 1. So I can say, well, I already had an equal sign. I don't know why I'm drawing it again. I'm going to have a 4x as my denominator, because that's what the common denominator is. And the top will be the 7 plus 3. So I'm going to get 10 over 4x. And then we do have to simplify things as much as possible. These are both even numbers, so I can divide everything by 2. And I get a 5. 10 divided by 2 is 5. 4x divided by 2 is 2x. Now, 2 and 5 are both prime numbers. It is not going to get smaller than that. So that is the answer I get when I add those two fractions together. They have a common denominator. And if we look at number 2, they also have a common denominator. So, well, they would if I wrote them correctly. This is supposed to be a plus. So we have 2x over x plus 6 minus 5 over x plus 6. So I know my denominator is going to be an x plus 6. And I have a 2x minus 5 on top. Well, that is just what it is. There's no simplifying that. So there's the answer. When your denominators are the same, it's pretty easy. Just add or subtract their tops. Now, on this problem, we have to find the least common multiple, okay? And there's different ways we can actually solve this. We can factor the denominator as much as possible and see what things are like or what we have to have. Or we can say, okay, I need to have this. Of course, that's not least common multiple. It's just finding a common multiple. But and that has to be in my denominator. And you would put parentheses around them, okay? And you would just say, okay, well, this first fraction's missing this in the denominator, and the second fraction is missing that in the denominator, and you'd multiply the tops and bottoms by those. Or you would just say, okay, then you could factor things. So this would be a 9x squared. I'm just dealing with the denominators at this, and then I could take out a 3x, and I would get an x plus 1. So I would say out of my constants, the biggest number that both 9 and 3 go into would be a 9. Okay, they both have to be able to divide out of it. Then I have an x squared and an x. Well, x squared can divide by x squared, but I can't take x and divide by x squared. So the bigger one is going to be in the least common multiple, as well as that x plus 1 has to be there somewhere, okay? So you could do it like that. And I'll do this problem in both ways. Okay, so this first fraction here, so I have 7 over 9x squared out of my least common, and that should be denominator, but it is the least common multiple of the denominators, but we are dealing with denominators here. So you find the least common multiple of the denominators, and we find the LCD. Okay, so it's missing the x plus 1. So if I want the bottom to have x plus 1, I have to multiply the top by x plus 1. Okay, and then it's going to be plus. That's a plus sign. This bottom one, it has a 3x, so I better write the problem here. Okay, but it needs to have a 9 instead of 3, so I have to multiply it by a 3. It has 1x, but it needs x squared, so I need another x, and it already has x plus 1. So if I take this this right here and I multiply it by 3x, I'm going to get my least common denominator. Same thing over here if I multiply this times this. Okay. I don't know what I just pushed. Oh, there we go. All right, so this fraction right here, the first one becomes 7 times an x plus 1 over 9x squared x plus 1. And then this is going to be added to 3x times x, which would be 3x squared, over 9x squared times x plus 1. Excuse me. So, oops, if I can get my drawing tool back. Okay. Now, if I add everything together, okay, we need to get rid of these parentheses first here. So, instead of just rewriting the whole problem, I'm just going to do it above it. 7 times x is 7x. 7 times 1 is 7. So this numerator right here became a 7x plus 7, okay? Now, my denominator stays the same. 9x squared times an x plus 1. And then I have to add the whole numerator, all the numerators up together. So I write them with by highest degree. So the highest degree here is the x squared there, that 2. So I'm going to have a 3x squared, 7x, and a 7. Okay, now that quadratic on the top, it doesn't simplify. I can't factor it out, so I can try to cross some things off. So I'm actually just going to leave my answer just like that, okay? Now, if you wanted to do this the other way, let me just move this up, if it'll let me. Well, let me scooch over to another screen and I'll do it. Oh, not that screen. Okay. So if I'm going to take, we had 7 over 9x squared plus x over 3x squared plus 3x. And we want to do it the other way where I said, okay, if I say all of this is my common denominator, if they multiply them together, okay, then I'm going to take this first fraction is missing everything in that second fraction. So 3x squared plus 3x, 3x squared plus 3x. And then I still have the other fraction. And then I'm going to say it's missing this denominator. So I'm going to multiply both the tops and bottom by 9x squared, 9x squared. Okay? And then we multiply things through and we simplify a little bit. So I end up with the top ends up looking like this. So I have 7 times 3x squared, so I get 21x squared. And I have 7 times 3x, which is 21x. And then over here, I have an x times 9x squared, which is 9x cubed. Okay? And then, oh, my goodness. And then on the bottom, I know I'm going to have 9x squared times 3x squared plus 3x. Okay. But we do need to kind of simplify things just a little bit because it looks really messy and I can see some things that would simplify out. So if we look at the numerator, what can I take out of each term? And I know I can take out, looks like a 3x out of everything. And I'm going to write it with highest degree first. So I'm going to start with this one. Okay. And 9x cubed divided by 3x is going to be 3x squared. This is the next highest degree. And 21x squared divided by 3x would be 7x. And then I have a 21x divided by 3x would be 7. And then in the denominator, I still have 9x squared, but I need to factor this one. What can come out of that? Well, if 3x squared and 3x, I can take out a 3x. So I know I'm going to have a 3x, and that's going to leave me with an x plus 1. And then we can cross off some things. I have a 3x here and a 3x here, and then it leaves me with everything that's left. So 3x squared plus 7x plus 7 over 9x squared times an x plus 1. And just leave your answer like that because that quadratic on the top does not factor. And so you can pick which method you use. It doesn't matter to me. Either find the least common denominator and multiply, or just multiply each fraction by the other one's denominator. And so now let's try one with subtraction. Okay, this one, I find it easier to do least common denominator because it has that quadratic in there, and multiplying a binomial times quadratic gets kind of messy and leads to more mistakes. So I'm going to go ahead and factor both of my denominators, okay? So if I factor this first one, I get x plus 2 stays on the top. Now out of the denominator, I can factor a 2 out of both things, and I get x minus 1. Still going to have minus, and then I have a negative 2x minus 1, and I need to factor this trinomial, and I know I'm going to end up with an x minus something and an x minus something because the two negatives have to multiply to positive 3, but add up to a negative 4. So that'd be a negative 3, negative 1. They multiply to positive 3, add up to negative 4. Okay, now for my least common denominator, I look at what I need. So if I look at just this first fraction here, I know I'm going to need a 2 as a constant. There's no other constant in my denominator, so I know that has to be there. If there was a constant, I just have to find the smallest number that both of them can go into. And I know I have to have the term of x minus 1. Each set of parentheses is considered its own term. Even if it's binomial, it has to be there. You can't just say, oh, well, here's an x and there's an x, so those are the same. No, it has to be that inside of the parentheses has to be identical, okay? So then I look at this second denominator here. Well, it has an x minus 3. I haven't included that yet, so I need an x minus 3. And then it has an x minus 1. Well, I already listed that right there, so I don't list it again. So, whoops, there. So my least common denominator is going to be a 2 times x minus 1 times x minus 3. All right. So we look at this first fraction right here, and the only thing its denominator is missing is the x minus 3. So I'm going to take both the top and bottom, and I'm going to multiply it by x minus 3. Okay, and this is minus. This second fraction, the only thing it's missing is this 2. It has the x minus 3 and it has the x minus 1. So I'm going to take everything times 2. So I have the negative 2x minus 1 that was already there. I'm going to multiply it by 2. Take the bottom, and I'm going to move the 2 in the front here on the denominator. There we go. All right, and then it's a matter of simplifying some things. All right, so we know no matter what, my denominator is 2, and it doesn't matter the order you write those two in, so just x minus 1, x minus 3, or you could have the x minus 3, x minus 1, whatever. That 2 has to be in front though. And then if I start with this first numerator, I need to actually multiply those together. So I'm going to get x squared minus x minus 6. Okay, and this has a subtraction symbol in between. So I'm going to subtract everything in that second numerator. So I am going to put parentheses. And I have 2 times both terms here. So I'm going to have a negative 4x minus 2. Okay, so I want to make this so it's a positive, so I can get rid of the parentheses. So if I change this to a plus, I'm distributing that negative. So I have a negative times 4x gives me a positive, and a negative times a negative 2 gives me a positive, okay? And then I can kind of just ignore these parentheses here. All right, so let's simplify what's in the numerator. So I have x squared, I have a negative x, and a positive 4x. So that's going to be a positive 3x. I have a negative 6 and a positive 2 is negative 4. And then I have my denominator, stayed the same. And let's see if we can factor that top. Well, what can multiply to negative 4 but add to a positive 3? is going to be an x plus 4, x minus 1. Those multiply to negative 4, add up to 3. And then in the denominator, I have this. And it looks like we have some things that are the same. I have an x minus 1 and an x minus 1. Now, because I'm crossing this off, remember, that means x equals 1. It's not, so that's going to be x can't equal that in my answer. So when I write out my final answer, the numerator is left with an x plus 4. The denominator is left with a 2 times an x minus 3. You do not need to multiply that 2 back in. It just leaves room for more mess. Just leave it like this. But we are going to say, oops, sorry, that x cannot equal that 1. All right, so that is how you multiply, that is how you add and subtract rational expressions. You're ready to do the practice.